Hello everyone, my name is Xiantian Sun and this is my system engineering midterm presentation. Today I'm going to talk about flight management system. This is a needs analysis for the flight management system. Flight management system is widely used on civilian aircraft, and always the stability and the safety of aircraft is first considered. And also, so many aircraft companies are looking forward to the advanced autopilot system, and so in this way they can reduce the cost of labor and the fuel, and also it can reduce the workload for the aircraft crew. And next one is operational analysis. Now, as we already know, the workload for flight crew is very heavy, and they have to send out instructions and receive information from different airport and aircraft. They have so many communication. In this way, they can operate operate the flight safety. And the next one is complexity of cockpit instruments is very high. So there are so many push buttons and instructions, and also the airport code for the pilot need to memorize, and it is hard for them to operate every stuff and memorize every stuff. And also the system integration need to be improved. There are so many subsystems of the flight management system, and nowadays each system can work independent. I think I have to make them have more connections and combine them together and become like an entire system, and so they will be easier for the pilot to operate. The next one is functional analysis. These are the few subsystems of the flight management system. And the first of all is a flight management computer. This is one of the most important subsystems of the flight management system. It works as a brain of the flight management system. It pre-programs large database and choose the most appropriate route for the aircraft. And also it can calculate and manage different functions and the subsystems. And the next one is automatic flight system. The automatic flight system is short for the AFS. It receives sensors information from different aircraft sensors, for example, inertial reference, GPS information. And then next one is electronic flight instrument system. Basically, it displays all the information and a flight emergency to the pilot. The next one is navigation system. The navigation system receives the different information from the AFS, which is automatic flight system, and then it can locate aircraft location, and then send the information to the flight management computer and let the FMC calculate the best way for the aircraft. The next one is feasibility analysis. And nowadays, the improvement of coding generation and validation lead to more accessible to update the flight management system. For example, the AI technology. Now there's so many AI technology. It can generate the code and the validation by itself. In this way, it will reduce the time of the calculating part, and the flight management computer will work more efficiency and reduce the cost and time for the company. The next one is new technology and the theory. Today I'm going to talk about the 4-dimension guidance, which I'm going to talk more later. And the next one is cost is affordable compared to the profit. There are so many aircraft companies make the huge fundings for the advanced flight management system, and definitely it will make them more money, and also the research will have money to do what they want. The next one is needs validation. For the advanced flight management system, it have to have a connection to the current flight management system. So the new operation should be easy to study, so the pilot doesn't have cost so many time to study the new operations. And also the flight management system should be affordable for the company and the aircraft, so they can update the new system together. And the next one is the new system should fit various aircrafts. So it cannot just like fit one or two type aircraft. It should be widely used. The next one is concept explanation. And first of all is the four-dimension guidance. The four-dimension guidance is a new theory for the aircraft. And as we know, the current use of the dimension guidance is three-dimension guidance. The difference between three-dimension guidance and the four-dimension guidance is four-dimension guidance added the time requirements to the three-dimension position information of the aircraft. The basic concept is to accept the arrival time requirements before or during the flight, and to accurately control the flight process in order to arrive on time. And in this way, definitely short the aircraft spacing, eliminate unnecessary waiting time, and improve the airport under a guarantee of safety. In order to obtain the four-dimension guidance, many work already has been carried out aboard in recent years. The relevant research institution affiliated to the National Spacing Administration of the United States and the Lockheed Corporation used B-727 and the Aircraft 1011 aircraft to conduct flight tests of the 4D flight management system under the air traffic control environment measured by the time-based route. And the next one is adopting advanced system structure. And as we all know, there are so many advanced system structure already being invented, and we just need to add them to the current system and test which will fit the best. And also it will have a test for the reduced time and the reduce the cost. And the next one is development of system integration. Now, as we already know, the subsystem of the flight management system now work independent. We have to make them combine together and have some entire function. So in this way, it will be easier for the pilot to operate, and also reduce the operational time and reduce the communication between airport and the aircraft. The next one is modeling aircraft. The modeling aircraft are mainly into two engine modeling. Into two main modeling. One is engine modeling. The next one is atmospheric environment modeling. I'm going to talk more about the modeling aircraft because this is the concept definition I choose. And also for the concept explanation, we can improving the air traffic control environment. As we already know, the air traffic environment is very poor nowadays, and so many flights has been delayed, and the waiting time for the users are very long. And improving the air traffic control environment with the fuel crisis and the saturation of the air traffic field in the peak of the terminal area landing. The airspace control department is required to provide system and the procedure to support the best cost of flight and reduce the delays. The implementation of these plans will affect the work of the flight management system on board. Due to the improvement of the air traffic control environment, investment in huge performance facility is required, and it makes a long time for all equipment to be put into use. And the next one is my concept definition, which is modeling aircraft. The modeling aircraft is mainly into two models as I find research online. One is engine modeling. The next one is atmospheric environment modeling. The engine is the exclusive control mechanism of the flight management system and is the main source of aircraft power. The working characteristics of the engine are different in different flight stages. Different flight stages such as climbing, cruising, and sliding. Therefore, the establishment of suitable engine model is required to design the thrust management system, develop the flight management system guidance law, and optimize the trajectories. And aircraft engine models mainly include slow train performance, thrust model, fuel flow model, and some restrictions. And next one is atmospheric environment modeling. It is the change of atmospheric environment. For example, wind, temperature, pressure has a great influence on the performance of flight management system. It directly affects the optimization process and the optimization performance of flight management system for flight trajectory. Studies have shown that changes in wind speed and wind direction will directly affect time required to fly over fixed distance. Temperature changes affect the magnitude of the vacuum velocity and the geometric highest change rate during climb and decline phase. In addition, the size and direction of the wind also affect the value of the optimal cost index when optimizing the trajectory. So when we have these two modeling, we can use for the flight management system. In this way, the flight management computer can calculate the best way to make the flight operation, for example, climb or decline. And in this way, definitely will save the gas, and also it will reduce the time of the flight and reduce the cost of the company. The last one I'm going to talk about is a challenge for the modeling aircraft. Definitely the pilot needs time to learn the new operation, and sometimes the new system may be complicated, so they need much more time to learn new operation. And the next one is some airports still use the old system. So in this way, the connection between the new system and the old system should be strongly related. And also, the cost should be affordable for the aircraft, so they can all update to the new system. This is my presentation for today. Thank you for watching.